So now please turn to page 16. This one is called polynomial function, okay? So just quickly recap what we did before. It was polynomial equations, right? And then after you factor the polynomial using the b over a, the factor theorem, and then the answer that you get for x, right? If we try to graph, it represents the x-intercept, okay? Because these are the numbers that makes the y values equal to 0, right? Makes it equal, make the whole equation equal to 0, okay? So another name for that is called the x-intercept. So the difference between equation and function is the equation finds the x-intercept, and then function has the x and y, so you are able to graph, right? Function, it takes the input, right, and then give an output. Okay, so let's go over the basic definition, okay? When you are given a function, how do you know it's a polynomial function or not, right? Because there could be other kinds, right? It could be rational, right? It could be radical, okay? There are many different kinds of functions. Okay, so the definition for polynomial functions, it must satisfy two conditions. Okay, so first one, the coefficient of highest degree variable is not 0. Okay, non-zero coefficient. Okay, so what that means is, for example, if I have a degree 3, right? So for example, if I want to have a degree 3 polynomial, so for example, you can have y equals to 5x cubed minus 2x plus 8, right? So you have a highest degree term, which is this one, and its coefficient is 5, right? So you cannot have a 0 as the coefficient for x cubed, okay? Otherwise, it will disappear, right? So this number, right, if it's degree 3, then x to the 3 cannot have coefficient of 0, okay? So that's basically what it's saying, right? So if it's 0, it becomes degree 1 for this one, right? Because there's no, the exponent after this will be x to the 1, so it becomes degree 1. So this one cannot be 0, okay? Non-zero. Oops. Okay, I need to restart the app. Okay. Give me 1 sec. It just crashed. Okay, so can you guys all see the screen now? Can you raise your hand if you can see the screen? Okay. Yeah, okay. So over here, back to here again. So this one is non-zero, okay? So that's for the coefficient, right? Next thing is about the variable. So like the x. So variable, variable cannot be inside the denominator. So the first one is the denominator. Okay, and the next one, it cannot be in the exponent. Third place, it cannot be inside the radical. Okay, so 3 places it cannot be in the variable. You cannot put a variable there. Otherwise, you cannot call it a polynomial function. Okay. So for example here, right, this one, you have a degree 3, right? Degree 3, and it says it's degree 3, so you look at the exponent is 3, and also check the coefficient is not 0, right? Then that one is a polynomial. And also all the variable, right? The x, all the x, they are not in denominator, not in exponent, and not in radicals, okay? So question 1 is very easy. You just check the two conditions and then determine if it's a polynomial. So you can write yes or no. And if it's no, write down why, okay? For example, you write down whether it's the variable is in different places, okay? So I'll let you try this one by yourself, okay? So write down the reason if it's no, okay? So raise your hand if you finish these 6. I can go over first one, okay, to help you get started. So question A, is this one a polynomial? Cindy?
No.
Because?
The variables in exponent.
Yes, very good. Okay, so you can just write the word exponent, okay, because the exponent has a variable. So this one is actually called a exponential function. Okay, you learned that in the log, right? Log and exponent. So this one belongs to exponential function, not a polynomial. Okay, so finish all 6 and then raise your hand. Okay, so let's quickly check the answers, okay? So question B, Donna, what do you think? Yes or no?
Yes.
Okay, that one's yes, very good, okay. Question C, Tiana, yes or no?
Yes.
This one, yes, okay. Anyone says no? Eric, what do you think? Yes or no? Eric, is your mic working? I cannot hear you. How about Ray?
I said no.
You said no, okay, and what's the reason?
Because on the x is -2, so it puts it in the denominator.
Right, okay, so this one is trying to trick you here, right? The exponent has a negative exponent. So if you rewrite that term, it will look like 3 over x squared, right? X has an exponent negative. So actually it goes down to denominator, even though in the question it looks like it's not, right? So this one is because of denominator has a variable, okay? So sometimes they will try to trick you, right? By writing it like a polynomial. Okay, how about D? D, Cindy, what do you think? Yes or no?
Yes.
Yes, okay. So this one, even though it has a radical, right? But then that radical doesn't have a variable, so that's okay. Okay, it's still a polynomial. Okay, question E. Eric, are you able to?
Can you hear me now?
Yeah, I can hear you now.
Okay.
Okay, so yeah,
No,
no, because
denominator.
denominator, very good. Okay. Okay, question F. Tiana, yes or no?
No.
Because?
X is in square root or radical.
Yeah, very good. Okay, so you can write radical. Okay, so just a simple rule to check if you are given a polynomial or not. Okay, next thing we're going to talk about is the graph. Okay, we're starting to do some easy graph first. Sometimes the graph can have symmetry. Okay, so different kinds of symmetry. So there are two kinds here. The first kind is, okay, let's put it down here, okay? The first kind of symmetry is symmetry over y-axis, okay? So an example will be like a parabola, okay? The parabola that has vertex right in the middle, right? Y-axis is right in the middle, so it's like a mirror, right? So we call that a symmetry. The second kind of symmetry is when you have symmetry around the origin, okay? So symmetry around origin, okay? For example, since you have learned the trigonometry graph, right? The sine graph will have a symmetry around origin. So what's happening here is, imagine if you turn this graph 180 degree, right? Turn this wave 180 degree, it will look the same as before. Okay, so turn, right? Or you can turn your phone, right? Or your screen right now, turn 180 degree upside down, then it will look the same as before. So if that happens, we call that a symmetry around origin, okay? So the rule to check that, right? For example, if you see a polynomial, right? And you want to see if this one has a symmetry or not. If it's symmetry over y-axis, okay, like the parabola one, so you can use your knowledge about transformation. When we learn transformation, we learn reflections, right? So for example, this parabola, if I reflect over the y-axis, it should look the same. Okay, so what was the rule for having a function that reflect over y-axis, right? How do I tell? Anybody remember? What's the rule for reflecting over y-axis? Anyone? When we learn about the RST. Cindy, do you remember? Rule for reflect over y-axis.
X is negative.
Yes, very good. Okay, so if I reflect over y-axis, you must have negative with the x, right? So this means reflect over y-axis. So if I reflect over y-axis and it still look the same, okay, the same means I put equal, same as before I reflect, so without the negative. So if this happens, then it's called symmetry over y-axis. Okay, so let's see how we can use this rule to check. Okay, so you can highlight this one, reflect over y-axis. So for example, what we have here is the y-axis. Okay, we're going to start with f of negative x. Okay, so negative x means the input is negative x. Okay, so for example, if you see f of 5, you will put 5 into the x, right? Here I have f of negative x, so I'm going to put the negative x into all the x places, okay? And then see what happens. So first one is the x squared, and then x squared minus 4. right? So the input is negative x, and I put negative x. And then we'll simplify this, okay? Negative x times negative x will become positive x squared, right? And then same thing with the inside. The inside negative x squared will also become x squared. And then minus 4 just stays. So now if you look at the simplified expression, it looked the same as the original, right? Even though we're subbing a negative x, it disappears. The negative disappears because of the square. So it equals to original function, okay? Given from the question, right? Up there, right? This one, the question that they give you is called the f of x original, okay? I input the negative x, it become the same as before. So without graphing, I know this one will have a symmetry over y-axis, okay? So this is how you can check, okay? So now I want to graph them now, okay? So now we are going to use the what we learned last class about finding x-intercept, okay? So we'll take the function, okay? So let's write it down, x-intercept. The function is x squared minus 4, and we will make it equal to 0, okay? And I want to factor this one. Which part can be factored further? Donna?
X squared minus 4,
Yeah.
it turns into x plus 2, x minus 2.
Very good. Okay, so that's a difference of square, right? So we factor into small brackets, right? And then we solve for each one. So you would have x-intercept at, from the first part, right? From here, you get 0, right? From the next one, you get negative 2. And then next one, you get 2. Okay, so those are the x-intercepts. All right, because we just made the y become 0. Okay, the 0 that you see here is sub it into the y in the question, right up there. Okay, so we'll plug the points now. Okay, x-intercept, we have 0, negative 2, and 2. Okay, and then right now we don't know which way it goes. Okay, later on, starting next page, I'll show you how to draw, how to determine which places to start a curve. Okay, right now all we know, the graph is symmetrical. Okay, symmetry over y-axis. So for this one, it will look like this. Okay, we don't know how tall it will, how low it goes. Okay, we just know that it will be symmetry around y-axis. Okay, so left side and right side look the same. Okay, so maybe I can show you with decimals later. Okay, yeah, so let me finish the right hand side. Okay, so let's look at right side now. Right side is symmetry around the original. So the rule for this, okay, so think about this sine wave. If I reflect this graph over the y-axis, okay? If I reflect it over y-axis, okay? What would it look like? Can someone draw it out on the screen? Ray, can you draw the picture? If I reflect this one over y-axis. Yeah, very good. Okay, so it flips. Left side goes to the right side, right? The bump, right, goes to the right side, and then the lower part goes to the left side. Okay, now if I take the same graph, okay, the red one, the original one, instead of reflect over y-axis, I want to reflect over x-axis. All right, so Eric, could you help us draw that? If I reflect over x-axis. Yeah, okay, very good. So the top part will go to the bottom, bottom part will go to the top. So you can see that it will look the same, okay? So it's different from the reflect over y-axis. Let me clear the drawing first. Okay, so before, right, was reflect over y-axis look the same as before, look the same as original, and then for this one is two reflection, and then they will look the same. Okay, when this happens, then we call this symmetry around origin. Okay, so the two graph, right, look the same. All right, so same rule, we're going to use the transformation to help us write the rule out. Okay, so reflect over y-axis will be f of negative x, right? And if it's reflected over x-axis, the negative should be outside, right? Not attached to the x. So the two graphs, they should look the same, should equal to each other. Okay, so we can write that down. This is reflect over y-axis, look the same as reflect over x-axis. Okay, so that's the rule for symmetry around origin. Any questions so far? Okay, so we are going to test this out, okay, for this one, okay? So the function that we have is this one, right? This one is the original, okay? We want to check if this one has a symmetry around origin. So we start with f of negative x first, okay? We'll try to make it into reflecting over y-axis, okay? So we'll sub it in x cubed minus 9x, okay? And then we sub in the negative x and negative x. And we'll try to simplify this one. All right, so can you simplify this and then raise your hand when you finish simplifying? Simplifying means try to get rid of all the brackets, okay? So raise your hand if you're done simplifying. All right, so can I have Eric? What does it look like?
Negative x cubed plus 9x.
Yeah, so plus 9x. Okay, so this is this expression, right? This function right now, what you have is reflected over y-axis. Now we are going to put the negative in front of the original function, right? Original function is the question, right? So we take the original, which is x cubed minus 9x, and we take that multiplied by negative, okay? So what that does, well, it will make the original function flip over x-axis. And to get rid of the brackets, we just bump in, right? The negative will share in. So it becomes negative x cubed plus 9x. Okay, so now you can see that the left side and the right side, they are the same. Okay, so without drawing the picture, we know this one, you should have a symmetry around origin. Okay, so this is how you can test, right, when you are given a function. So let's actually draw out the function now. All right, so same thing, we need to get the x-intercept, okay? And to get the x-intercept, you need to factor. How do we factor this one? Tiana, how do we factor this one?
We factor the x out first.
Very good. So that's a GCF. So we take x out. What's left? Tiana, still you?
It becomes x squared minus 9.
Yeah. Okay. So once you see x squared minus 9, you should remember that on the left side we have something similar, right? Difference of square. So this one can continue factor more, right? We get x plus 3 and x minus 3, right? Difference of square. So we have 3 roots, okay? 3 x-intercept again. So x-intercepts are, Cindy, what are the x-intercept now? Cindy, you there? What's the x-intercept?
Zero, wait, 3, -3, and
Yep. Yep, 0, 3, and negative 3. Very good. Okay, so let's follow that. We have 3 points, negative 3, 0, and 3. Okay, so same thing for this one. Right now you would, because to go through the points, right, there are a couple ways you can make it go like this, right? That's one way, right? You could make it go like this, right? That's another way, right? There are infinite number of ways. Well, not infinite, many ways, right? So right now you haven't learned how to tell which way. So I'll give it to you first. Okay, right now the only thing you know is you have a symmetry around origin, right? So this one will look like this. Kind of like the sign, right? So think about this one, right? If I rotate this 180 degree, right? Turn your head 180 degree, it should look the same as before turning, right? So this one is a symmetry around origin, okay? 2 kinds of symmetry. Right, so that's part of property that you need to know when we try to graph functions. Okay, this whole chapter is all about graphing. All right, so starting on the next page, we are going to talk about the rules for telling like where the arrows, right? You can see that I know where the arrows are, right? For the first one, I have arrow in the first and second quadrants, right? And then the second graph, we have first quadrant has an arrow, and then the third quadrant have the arrow. Okay, so what are the rules, right? How do you tell? So that's what the next page is about. Okay, so the location of the arrow, it depends on 2 things. One is the degree. Okay, degree means the highest exponent of the polynomial. Okay, depending on what kind of degree you have. So you could have an even degree or an odd degree, right? Even is 2, 4, 6, 8, odd is 1, 3, 5, okay? Second thing you need to check is the highest degree coefficient, okay? So we call that the leading coefficient. So if you get a positive, right, look at the chart on the top left, right, positive leading coefficient, right, then you get one kind of graph. And then if you get negative, you get another one, okay? So by having combination of these two groups, right, degree and leading coefficient, you can make 4 different combinations. So we'll go through one by one, okay? And then see what happens, okay? So find out the rules here. So the first one, we have an even degree. So how do I know this one is an even degree? Donna? How do we know this function has an even degree? How do you tell?
Because of the x's.
Yeah, and what about it? Can you be more detailed? How many x's do you see?
4.
4 x's. Yeah, very good. Okay, so if you see 4 x's, that means if you extend all the brackets, right, eventually it will look like, right, all the x, if you multiply them together, you get x to the 4, right? And the coefficient we have is 1, okay? And then plus something, 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 right? The rest you need to expand to figure out. But all we care is the degree, right? Degree is 4, that's an even number. Coefficient is 1, that's a positive, right? That's all we care. Then anything that has even degree positive, they will have same location for arrows, okay? So to remember this rule, you can think of the easiest even degree that you know, okay? So the lowest degree that you know is x squared, right? That's also even, right? And then you also have coefficient of 1, positive, right? Positive leading coefficient. So even and positive. So this graph you already know. This one is a parabola, right? We can draw that out. So all the even and positive will have the same location for arrow, right? So you have arrow in quadrant 1 and 2. So you use this one to remember the rule. Okay, so we know that for the graph that we are going to draw, we'll have the same location of quadrant. Okay, so you can go down to the table here. You can write quadrants 1 and 2. Okay, so even positive quadrant 1 and 2. You just use the parabola to remember this. Okay, even positive quadrant 1 and 2. So later I will need you guys to memorize the rules, okay? Once after we go over all 4 of them, okay? So very easy, right? Next thing we need to figure out is the x-intercept. Okay, this one is already factored, right? So by looking at the brackets, what are the x-intercepts? Oh, first of all, this one is degree 4, right? We can fill that in. Degree is 4. Quadrant is 1 and 2. So where are the x-intercept now? Tiana?
-4,
Yeah,
2,
yeah,
-1, 0.
yeah, very good. Okay, so we get 4 x-intercept. So we just follow that and then plot the x-intercept now. Okay, -4 is there. We have a -1. We have a 0. We have a 2. Okay, and because it belongs to even positive, so we know the arrow will be in quadrant 1 and quadrant 2. Okay, so we just make the line go through the x-intercept, right? So x-intercept means where the graph will touch the x-axis, right? However, we don't know how low the curve will go. Okay, so usually the wider the space is bigger between the points, it will go lower. Okay, it'll go up. This one is closer, right? So it'll be more shallow, right? And then wider, go lower, and then up. Okay, so this one is the a rough sketch. Okay, so it has the arrow in the same place, right? Quadrant 1 here, quadrant 2. Okay, now the number of turn. Number of turn is, imagine that you're driving on the road, right? This is the road map. So the turn is like where the valley is, right? And then where the hill, the bump, right? So you have one turn, right? That's one. That's another one, right? That's another turn, so 3. Okay, so total number of turns is 3. Okay, so let's double check with the decimals. Okay, so let me pull out the decimals and you can compare, right? See how close our graph is. Okay, give me 1 sec. I'm gonna turn on the decimals. Okay, I'm going to start a new share. This one. Okay, and graphing. Okay, so we have y equals x plus 4, right? And then x minus, what was it? Next one is x minus 2. Yeah, x minus 2, x plus 1. X plus 1 and x. Okay, so you can see over here. So actually it goes down to negative 30, right? As you can see there. But the shape, the general shape is the same, right? So, and also the arrow, right? It keeps on going up. Arrows are in quadrant 1 and 2. Okay. Yeah, I think you can adjust, then you can see the whole picture. Okay, so that's our graph. Okay, let's look at the next question now. I'll change the sharing. Okay, did everybody see the graph? Okay, can you raise your hand? Just want to make sure you guys saw the graphs. Okay, so now I turn back to the screen. Okay, we'll look at the negative, okay, the bottom part. So same thing, it's still even degree, but you would have a negative leading. So we'll look at the x now, okay, to check if it's even and negative, okay. So if I expand all the x's, right, multiply all the x out, the x plus 2 has a square, right? So that's the same as having two brackets that are both x plus 2, right? So you would have x times by x times by x again, right? And then multiply by negative x from the other brackets. So when you multiply everything out, it will give you negative x to the 4. Okay, and then plus something something. right? So that's why this one belongs to even, right? Even exponent, and then negative leading. So the graph that we can use to help us get the quadrant is the parabola as well, right? But with the negative at the front. Okay, so this one also has an even, has a negative. Okay, so instead of open up, right, it will be opening down. Okay, so all the even negative will behave the same way. All right, so we'll graph that out. Okay, so this one will be opening down. So the arrows will be in quadrant 3 and 4. Okay, so now we can put that into the, so this one has degree 4. Okay, we can write that down. Degree 4. Quadrants should be 3 and 4. Okay, quadrant 3 and 4. Now I need to get the x-intercepts, right? So once again, the function that they give you is already factored. All right, so can you take a look at the function, okay, and then write out the x-intercept. Okay, when you finish writing x-intercept, you can raise your hand. All right, so erase, where are the x-intercept?
0, -2, 3.
Yep, 0, -2, and 3. Okay, so let's graph it on the grid. So 0 right in the center, -2, and then 3. Okay, and because it belongs to even negative, right? So we know the arrow has to be here, right? Has to be in quadrant 3 and 4. So how are we going to connect them then? Okay, I'll let you guys try it first. Okay, and I'll ask one of you to draw on the screen. Okay, so I'll give you a couple seconds, draw it out. It has to touch those points, okay, those x-intercepts. Okay, Eric, can you give it a try? You can show us what you have on your paper. Okay, so it went through the -2 and then went through the 0 and then looks like it just touches the 3, right? Yeah, so the arrow is in quadrant 3 and 4. Yeah, that works, right? Any other way? Any other people draw differently? Donna, do you have the same drawing?
No.
How did you draw it? Can you show it too? Okay, so your color is green, right? Oh, okay. Yeah, that also works, right? So it goes through the -2 and then bounces at 0 and then goes through 3. Yeah, that's another way. Any other ways can we do it? Cindy, how about you? Do you have the same as one of those two or different?
The same as Donna's.
What? I can't hear you.
Same as Donna's.
Oh, same as Donna. Okay. Ray, how about you?
I wrote the same as the pink one.
The pink one. Okay, so Eric. Anybody else? There's another way though. What's another way? Tiana, do you have different?
No, I have the same as Eric.
Okay, no one got different ones? Okay, then I will draw the different ones. Okay, so as you can see, Eric, right? Eric is bouncing off 3, right? And then Donna is bouncing off at 0. So I could also bounce off at -2, right? So if I do that, it will look like this, right? Bounce and go over, right? That will also work. So we have 3 options. Which one should we choose, right? So we need to know a rule why we choose the graph, right? Which way to do it. Let me erase this first, okay? So what you can do is you can use what you already know, okay, to understand it. For example, this one, x squared, right? If you get a square, it's sort of telling you you have x times x, right? Because x squared. So the 0 should be x, the x-intercept should be x equal to 0. And one is also the same, x equal to 0. So you have 2 x-intercept that are the same. So if you have 2 x-intercept that are the same, the only way to make that happen is for it to just touch it and then bounce back, right? So that's why for the parabola with x squared, it will just touches the origin, right? It cannot go through, right? Because if it goes through, then it must come down at a different place, right? It will create a different x-intercept. But since we need to have 2 of the same, it can only touch that place, okay? So that's the idea. Whenever you see a square, that means that location is going to be the bouncing place. All right, so now can you look at the function now? Take a look. Where should we make the bounce happen? Eric?
At x equals 0.
X equal to 0. So you look at the x equal to 0, that means it's the first one, right? Do you see a square for the...
Oh no, okay, at x equals -2.
Yeah, x equal to -2, right? If you see the x plus 2, okay, let me highlight that. Okay, x plus 2 has a square, just like the inside the green box, right? We have x squared. So whenever you get a square, that means you have 2 roots that are the same, right? So the only way for that to happen is to just touch it and bounce back, okay? So let's write down we call that root that repeats, this one, okay? Down here, x-intercept, the -2 is called the double root. Okay, double root, the graph or the curve, okay? You can write graph or curve, bounces. Okay, so if you see like x plus 2 to the 4, it will also bounce, okay? Anything that's even number, it will also bounce. So we know it has to bounce at -2. The other one, they don't have square. So it will just go through it, okay? So it goes up, bounces, right? Goes up, goes through it, right? Because it doesn't have square, right? And then go through the 3 as well. Okay, so let's check with the decimals, okay? And number of turns. How many turns did we make, Tiana?
Three.
Yep, we have 3 turns, okay? 1 turn here, right? Another turn down here, and then 3, okay? So once again, I'll share the decimals, okay? And then we'll check that. So x plus 2, 3 minus x, okay. Let me pull that out. Okay. And you can all see the decimals now, right? Okay. So y equals x plus 2 squared, right? So you can see so far it has a bounce already, right? At -2. Let me pull that out. Right? There's a bounce. And then we have one more place. One more place is at, oops, 3 minus x. Right? So you can see, compare this graph with what you had, okay, on your page, right? The shape looks similar, but we don't know how high it goes, right? This one, the highest is around 30, I think it's 30, 35, 32, yeah. And then lowest, right, the valley here, right, we don't know, okay? If you want to know how to calculate the highest point, lowest point, you need to take calculus, okay? So let's go back to the sharing. Okay, go back to the previous one. All right, so any questions so far? Can we move on to odd degree? Okay, can you raise your hand if you have no questions so far? Okay, so you'll know how to tell the bounce, right? Make sure it's double root, okay? It has a square, then you get a bounce. So let's look at odd degree now. So odd degree will be very similar, right? So this one is an odd positive, right? So we'll look at all the x and then multiply them out, okay? So x times a negative x times another negative x, right? So that will give you positive, right? Negative, negative, positive. So positive x cubed. And coefficient is 1 here, right? Plus dot, dot, dot. So this one has an odd degree and a positive coefficient, 1. So what should we compare with then? Okay, for even degree, we compare with x squared. What about odd degree? What should we compare with? Cindy, what do you think?
Wait, just that?
Yeah, just x, right? The lowest one, right? One odd means 1, 3, 5, 7, right? So lowest one will be y equal x, and that is something that we already know, right? This one has a degree of 1, right? Coefficient is also positive, right? Y equal x. I would just write y equal x, okay? And the graph for this one, hopefully you'll know what it looks like, right? Tiana, what does this one looks like? Y equal x. Where are the arrows? Or you can draw it on the screen, okay? Y equal to x. What's the graph look like? Yeah, okay, going diagonal. Yeah, very good. Okay. Let me erase that. Okay, yeah, okay, good. All right, so I'll draw it on the screen now. So it goes this way. So you can see the arrows are in quadrant 1 and 3, okay? So anything that has odd and positive will show up the same location for arrow, okay? We'll have the same location. So this one, that's our rule for odd, positive. What's the next thing we should do now? Donna, what do we do next? We found a quadrant. What should we do next to draw the graph?
The x-intercept.
Yes, okay, the x-intercepts. Okay, so where are the x-intercepts this time, Eric?
0.
0. Where did you get the 0?
Or, oh wait, no, okay. 1,
Yeah,
2,
yeah,
and 6.
and 6. Yes, okay. Yeah, there's no 0, right? Unless there's an x by itself, then you have a 0. Okay, so this one has 3, and degree is 3. Okay, and then you know the location of the quadrants, right? So based on these location, right? Based on these information, can you guys all draw the picture? Okay, this time by yourself. When you got a graph, you can raise your hand, okay? And I'll get the decimals ready. Okay, please raise your hand if you finish the sketch. We have x-intercept of 1, 2, and 6. Right, so let me share the screen, okay, for the decimals, and then you can compare. Okay, so this is what I have. Okay, you can put down your hand if you have the same, okay? Right, so goes through 1, right, goes through 1, and then goes through the 2, and then go through the 6, right? So it looks like this. Donna, do you have different?
No.
Okay, then you can put down your hands, okay? Yeah. Okay, so let's copy that down. So go through that. Okay, so just a rough sketch, right? So we have quadrant 1, quadrant 3. And number of turns, this one has 2 turns. Okay, last one we have here is the odd negative, okay? So odd negative, we checked all the x. We have negative x squared times it by x. So we know it will end up with negative x cubed, right? This one actually not too difficult to expand everything, right? So this one you will have plus 4x squared, right? Just 2 terms.
Are you writing something?
Oh yeah, sorry, I need to switch back. Thanks, Donna. Okay. You see it now, Donna? Yeah. Yeah, okay. So this one, the next one down here, okay? It's an odd negative. So if you expand everything, it will be negative x cubed, right? So you have a odd exponent and negative leading, okay? So the function that we should compare with should be what? Eric, what should we compare with?
Y equals negative x.
Yeah, okay. So we'll compare with the opposite, right, of the y equal x. So the arrows, which quadrant should the arrows be in then? Cindy?
Wait, what was the question again?
Which quadrant should we see the arrows this time?
2 and 4.
Yeah, very good. Okay, the graph goes diagonal the other way, right? So arrow is in quadrant 2, quadrant 4. Okay, so we have highlighted there, okay, 2 and 4. So same thing, I'll let you draw the graph and get the x-intercept now, okay? Get the x-intercept and then make a sketch, okay? When you finish sketching, you can raise your hand. So quadrant 2 and 4. Okay, I would like to know the x-intercept that you got. Okay, this one is degree 3. Okay, what's the x-intercept that you have? Tiana?
0 and 4.
Yep, we have 0 and 4. So only 2 x-intercept. 0, 4. Okay, please raise your hand when you got a picture. Okay, so your graph, you should have arrows in quadrant 2 and quadrant 4. So how do we connect them? Cindy, can you try it? Draw on the screen. Okay, so looks like you have a bounce at 0. How do you know there's a bounce at 0? Huh? Cindy, how do you know you bounce at 0?
I don't know, I just guessed.
Oh, you just guessed. Okay, do you remember the rule for bouncing?
Which one?
For the graph on the left side, we talk about bouncing, right? Bouncing the curve, bouncing the graph. What was the rule?
Double root?
Yeah, if you get a double root, right? The one down here, double root, whenever you get a double root, the graph should bounce. Okay, so let's go back to here. Okay, trying to match your picture. Okay, so anyway, something like that. Okay, so do you have a double root for this function?
Yes.
Okay, where? How do you tell? Where's the double root?
0.
0, and where do you find, how do you know that one is a double root? Where should you look at to determine if it's double root or not? How do you tell?
I don't know.
Where did you get the 0 from?
The negative x cubed.
Say that again. From
The negative x squared x cubed.
square or cube? Very different. Square.
Squared?
Square, yes. Okay, you have to look at when you are trying to get x-intercept, you need to factor it, right? So you need to look at the factor form, okay? Instead of the one that's expanded, okay? This is very important. If you look at the wrong one, right, you can see, oh, x cubed, that's a triple root, right? X squared, that's a double root, then that doesn't make sense, right? You have to look at the factor one. The factor one has 2 parts, right? I'm using the green circle, right? One is the x squared, the other one has the x minus 4. Okay, so how do you tell which one is the double root? You said, Cindy, you said it's 0 because?
Because 0 squared times like x minus 4 is 0.
Say that again.
Because it would be 0, because if it's like negative x squared, then it's 0.
Yeah, I know it's 0. I know how you got the 0, but how do you know it's the 0 that is double root? Why not the 4? Why not 4 is not a double root?
It's squared?
Yes, okay, that's the key, right? So if the question is, instead of square here, I have a square on x minus 4, right? X minus 4 squared, then you will be bouncing at 4, okay? Instead of at 0, okay? So make sure you know why you bounce at that location, okay? So because of the square is at the x, right? Square is on the x, so the bouncing is at 0. Okay, it's not a guess. Okay, it's not a guessing game. All right, so let me erase your drawing. All right, and I'll show you the decimals one last time. Okay, this one has 2 terms. All right, so let's write that down, and then the 0 has a double. Okay, double root. Okay, and then therefore it's bounce. All right, so let me share the screen again. Decimals, I already typed it out. Okay, so there you go, right? So this one you can see it bounces at 0 and then goes up almost hitting 10, right? 9.481 and then goes through 4. All right, now one last thing, okay, before we have a break. Okay, sometimes you could get a triple root. Okay, let me share the screen again. So this one. Okay, so I want you to make a note on the side. Okay, at the corner here. So if I have, let's say, okay, you can write it down, note. Okay, instead of a square, okay, let's say I have x to the cube. Okay, and then x, I want to still keep it as odd negative, right? So let's say x minus 4 squared. Okay, so suppose after you factor, you get something like this. So what's the degree for this one now? Ray?
5.
Yeah, this one has a degree 5, okay? And Cindy, where is the double root?
0.
0 has a double root? How do you know?
Wait. What?
Huh?
Wait, what was the question again?
My question is, where is the double root? For this one we are doing.
Four.
Say that again.
4.
4, how do you know?
Because it's squared.
Yes, okay, so it's not always 0, okay? So you got to adapt to different questions. So this time, the double root is at 4, okay? So let's write down the x-intercept. X-intercept, you have 0, you have 4, but then this time, this one is the double, right? And then for the 0, is a triple, okay? So it's an odd number. So just like the other one, if it's like, if it's just x, right, it will go through. For example, all the other ones, right? All the other one, if it doesn't have a square, it means it's a degree 1, right? So it just goes through the points, right? For example, this graph, it goes through 0, goes through 3, right? Because it doesn't have a double. So same thing with the cube here. If it's not square, not 4, it will not bounce. Okay, it will go through, right? So this one will bounce for the 4. Oops. Okay. What's going on? Sorry, I hit the button, okay? The page flew away. Okay, back here. Come back, come back. Okay. All right, you guys can all see it. Okay, so we have double root for this one, for 4. Okay, so it bounce. For triple root, it will go through. So let's say we cross, okay? The graph will cross over, cross the x-axis. Okay? Do you like the word crossing or through? Cross is shorter, okay? Cross over. So when we draw the graph, okay, this is very important, okay? How to draw the triple, okay? Because you have x, x, x here, right? 3 x's, so you get 0, triple root. So 1 is at 0, 1 is at 4. This one is still in quadrant 2, quadrant 4, right? But the way of crossing is not going to be the same as before like that, okay? So this is not correct, okay? Because this one has a cube. So when you do the crossing, you have to make a little turn. So turn like that and turn again. Okay, very ugly here. Let me try again. So make a turn, right? And turn and go up, bounce, and back down. Okay, so watch out how I go through the 0. Okay, because it's triple, it doesn't go straight through. Okay, it has to make a little turn, kind of curve around, and then go through it. Okay, and then bounce at 4. Okay, so this one is bouncing at 4. Any questions? Can you raise your hand if you get this? Okay, just for triple, okay? You might see that, okay, for the homework. All right, so other than that, I think everything else, you just follow the rule here, okay? So before we go for a break, okay, I would like you guys to, each one of you have to say it out, okay? The simple rule for the quadrant, okay? So let's try it together, and then I'll ask each one of you to say it, okay? So you can say it on your end, okay? Even positive, 1 and 2, okay? Next one, even negative, 3 and 4. Next one is odd positive, 1 and 3. Odd negative, 2 and 4. Okay, you just memorize the green box. Okay, the 4 little graph of the green box, then that should help you, right? Even positive, you think about parabola. Even negative, also parabola but open down, right? Odd positive is a line going up. Odd negative is a line going down, right? Then you know the quadrant, okay? So you have to say the going order, okay? Start with the even and then the odd, okay? So if you feel you are ready for the little quiz, okay, you can raise your hand. Let me lower your hands first, okay? And you got to close your book, okay, when you do this. I trust you, all right? Okay, so let's check. E-Ray, you go first.
Even positive 1 and 2, odd positive 1 and 3, even negative 3 and 4, and odd negative 2 and 3.
Okay, very good. Okay,
I
then
mean 2 and 4.
2 and 4, yes. Yes, you're right. Okay, Donna.
Even positive 1 and 2, odd positive 1 and 3, even negative 3 and 4, odd negative 2 and 4.
Okay, yeah, for myself, okay, I find it easier to do all the evens together, okay, but maybe it's easier for you to do odd and even, okay, so up to you, okay. Eric, your turn.
Even positive 1 and 2, even negative 3 and 4, odd positive 1 and 3, odd negative 2 and 4.
Okay, very good. Cindy.
Even positive 1 and 2, even negative 3 and 4, odd positive 1 and 3, and odd negative 2 and 4.
Okay, very good. Tiana.
Even positive 1 and 2, even negative 3 and 4, odd positive 1 and 3, and odd negative 2 and 4.
Yes, very good. Okay, Samantha, give it a try.
Even positive 1 and 2, even negative 3 and 4, odd positive 1 and 3, odd negative 2 and 4.
Okay, very good. All right, so let's have a break and then I'll see you guys again at 6:35. Okay? Bye-bye.